Hey ladies and gentlemen, welcome back. So in this one, let's start with loops. Okay. So in order to loop, things are simple. So what I'm going to do is I'm going to mute all this code over here. Now we don't need the if and the switch statement, so I'm going to remove that. But I may need this kind of part, so I'm going to leave it there. But let's move it down so we can put some more code at the top. So there are a few ways to loop. There is the for loop, there is also the while loop, and then there's the do while loop, like this. Okay, so for, while, and do while. So of course, let's start with the for loop. So we don't need this scanner there, it's just there as a remembrance. So I'm going to mute it there so you can omit that if you want. Now a for loop is good for looping for a number of times, so repeating an action a certain number of times. So here I'm going to grab the system.out so I can print something. Okay, so here I just want to print some numbers, so I'm going to say number and say number 1 like this. So if I run this, it's going to print the word number 1 there on the screen, no doubt. But what if I want to print 20 numbers, and in each time I want to print, let's just print this 20 number of times, right? So I'm going to do a for loop. Now the way the for loop works is like this. So there's a for loop there, and this code in here repeats for as long as the conditions in there are met. So the first thing we need to do is initialize a numbering system here. So something to keep track of how many loops we have done. So usually that's an integer, so I'm going to say int I. Usually we call it I for no apparent reason, but you can call it A if you want. So int I is equal to 0. Now this tells us we are starting at number 0. So whatever you put here, that's where we are starting to count from. Then put a semicolon and put your condition here. So for as long as I is less than 10, we will loop. So for as long as this condition evaluates to true, then we are going to loop. And then since we are looping, I'll put another semicolon. The I must be incremented every loop. So we do that. So this means the I will add a 1 to the I every time we run this code from start to finish. So in here you can have a huge amount of code. It doesn't matter, 1,000 lines even, but it's going to loop this number of times. So what this means is that we're going to run start at 0 up to 9, which is 10 actually. From 0 to 9 is 10 loops. So we will reach 9, and then once we reach 10, the question will be is I less than 10? Now this is the same as asking is 10 less than 10, which is false. 10 is not less than 10, it's equal to 10. So at this point it will stop. So let's see this in action. So clear the screen. Let's do javac and test.java. Now you can just copy and paste this every time you want to compile to speed things up. So say java test, and as you can see, this has looped a few times, so it has printed that a certain number of times, which is actually 10. 4, 5, 6, 7, 8, 9, 10. Okay. Now what if we want to know what number we are on? Remember that I contains the current number we are on, so all we need to do is add to this string the I, whatever value of I is, we add it there like so. So again we compile because we've changed our code, and then we run our code. Okay, so there we go, number 0 to number 9. So that's how you loop through that, and knowing exactly what number you are on. Okay, so this is convenient. Now here, remember that you can actually put an equal sign if you want. That way you can say if I is less than or equal to 10, which means even 10 will be included in this loop. So we can see that rather quickly. So as you can see, this time 10 was included because of that equal sign, right? So that's how you do a loop like this, but I like it like that instead. Okay, now within the loop here, you can put if statements, right? So for example, I can say if I is greater than 8 over here. So if I becomes greater than 8, then here we can put a break, just like we saw in the switch statement. So what the break does is that it gets out of the loop that it currently is in. So it will stop looping instead. So if you say, if I is greater than 8, then exit. So here we only see numbers 0 to 7. So let's see that in action. And let's run it. Oh, wait, we went to number 8 actually. Wait a second, it starts with 0 and goes to 8, right? Ah, that's because it must be greater than 8. So unless I do greater or equal to 8, then it will stop at 7, right? So let's see. Because then it was stopping at 9 while it had already printed 8. So that makes sense. So then... Wait, what just happened? I just ran the Java file without compiling it? Oh boy. So you can do that, right? Who knew? You know, I didn't know that I don't have to compile stuff. Wow. This is revolutionary. Wow, so I can run the Java file. It actually compiles by itself. That's very good. So with that in mind there, what we can do now is, so you can see how to break through the loop here, right? Now there's also another keyword called continue. So break will actually exit the loop and stop looping. But there's also another keyword called continue, like this one. Now this one will continue. Let's put equal to, like so. So we're going to run everything. Let me put this up to maybe 15 or something. So if I is equal to 8, it says continue, which means skip this loop. So once it gets to this point, and then it says continue, it will ignore all the code that comes after this and just go back to the top and start again and increment the I there. So that's what continue does. So let's save that and taste it. Test it, not taste in the mouth. So Java test.java. Do I even need the .java at all? I don't. Look at that. Or maybe I do, because it seems that's the old compile. So let me try Java test.java. There we go. So I should include the .java. So as you can see, these numbers move from 0 to 14 as in anticipated, but 8 is missing as expected. So that's what continue does. Now here we can say or I is equal to 11. So here, if any of these is true, because there's an or here, then it will skip both 8 and 11. Let's see that in action. So Java test.java, and there we go. Look at that. Number 8 is missing, number 11 is missing as well. So that's what you can do with these loops. Now you can also put a loop within a loop. So like I am looping here, I can put another loop inside here. So then the break can use what is known as a label. So let's see that in action. So I'm going to do this. and I want to create another for loop within this for loop here. So I'm going to do, now you can do this kind of thing with any type of loop you want. So now I can't use I here because this will cause confusion. There's I here, and then here I'm declaring it again, which is a problem. So here let's change that to A, like so. So here we're going to say number I plus comma number plus A. That way we see both of these. We see what I is and what A is in this case. So here I'm going to change that to 10, and here 10 as well. That way it's easy to follow what's going on. So here we're going to loop 10 times, but within each time we loop, we're going to loop 10 times in there as well. So let's see that, how that works. So we're going to say Java test.java, and there we go. Look at that. So we're looping 100 times because it's 10 times 10. So you see there's 10 zeros, right? While these are changing, and then there's 1, and there we go. So these just look like numbers, right? 1, 0, 2, 0, 3, and then here we get to 10, 11, 12, 13, until we get to 99, I presume. Let's go back up here. Why is it scrolling so fast? Yeah, until we get to 99. So it loops 100 times because there's 0, 0 at the beginning, which makes it 100. So that's how you loop within there. Now you can put labels at the top here if you want to break. So let's see here. If I put a label, I'm just going to call it my label, and then put a full colon at the end. This makes it a label. So if at some point, at any point, let's reach number 12, for example, number 20, then we exit. So we only know if it's 20 if I is 2 and A is 0, which kind of makes 20, right? We're going to say if I is equal to 2 and A is equal to 0, then at this point we want to break. Now normally if I say break here, right, it's going to break this loop only. That's the normal thing, right? It's going to break this loop, but then continue the loop on top, which will continue this loop again until this condition is met and break again. Now I wanted to break both of these. That's why I've put the label outside both of these for loops. That way when I say break and say break to my label, it exits both loops like so, right? So let's test that. Clear the screen. Let's do Java test.java. Forgotten an A here. Alright, so you see as it got to 19, then it exited there. Now if you notice here, I did not use any brackets for this if statement. I just went ahead and put a line of code there. That's because if there's only one line of code in your if statement, you don't need to put these brackets like so. Those are optional. It's the same as if it were one line like so. This will still work just fine. So if whatever statement is, and then you only have one line there, no problem, you can do it like this. Let me put it back so it's easier to see. So there we go. We break at 20. We can break at 30 like this. So let's do that. And as you can see, it goes to 29. So it's breaking at 30. So that's how this for loop thingy works here. Now you can still use continue or break and stuff like that here as well. So continue. I don't know what continue would do here. Let's test it, right? Now you can put this label here, or you can put many labels. I can say my label 2 is over here, so that if you want, you exit up to here instead of all the way up there. But let's try this, just see what goes on here. So let's say java test.java. So it still works, but the thing is, when you continue, you still continue to loop. So here, if I look closely, 30 is missing because that's the one we are skipping over. So think of it this way: continue is skipping and break is breaking completely out of the loop. All right, very, very cool. Now, another way of looping is the while loop. Now, keep in mind that most of the stuff we put here works for the while loop as well. For example, the labels, etc., etc., and the break and continue. But we can loop in a very different way here. Let me grab this and put it there so that we do this here. Now, a while loop is simpler. It's like while, and then there's a condition, and then for as long as this condition is true, whatever code is in here will keep running. So let me grab that and paste it here. And I just want to say something like still running, like so. And then let's remove everything else. Okay. So what would be the condition here? Maybe we create an integer and say int a is equal to 0, right? So now here I can check the condition. If a is, let's say if a is if it's less than 10, right? Something we were using here. So int a, if a is less than 10, which is true because a is 0, which is less than 10, so this will run. Now the problem with this here is that maybe you haven't seen it or you've seen it already, is that we're going to have an infinite loop. That's because a will always be 0 because there's nowhere where we're changing the value of a, so this will loop forever. Now that is not good. So this is why in a while loop, inside the loop, you are supposed to remember to increment a at some point. That way you can say while this is less than 10. So to begin with, it's 0. But since we're adding 1 to it, eventually it will reach 10. Now, it's always a good idea, for example, to put this incrementer at the beginning here. This is just my personal preference, because putting it at the end here, sometimes if you have if statements in between here, they may prevent things from happening. For example, if I have a continue here. Where is this? Continue, like so, right? So this continue prevent this code from running, which means this has become an infinite loop again, because the continue says skip this level, we go back to there, and a is still 0 because we haven't incremented it, and we'll keep looping forever. So that's why in my personal experience, I've seen that it's better to increment immediately before you put any other code. That way, regardless what happens here, this number has already been added, and on the next turn it will be added again to make sure the condition changes. Now, you don't always have to do this, right? What you can do is you can put an if statement and check for some things, because it's not always that you're going to use the while loop for numbers like this. Sometimes you may asking the question, while a file or while a number exists on file, do something else, and then check later again if it exists and do something else. So it's not always about numbers like this, but this is a basic idea of a while loop. So let me remove this. Now in here also, still running, we can say at, and here we can concatenate a, just like with the for loop. So let's see that in action. So java test .java. So there's a while loop still running up to 10 there, right? So simple and straightforward, right? I prefer this one. If you don't want to make infinite loops, for loop is better, because you don't need to remember to do this, because it's part of the instantiation process here to add that there. Now, one thing I also forgot to mention is that you can do a for loop in reverse. So I just didn't mention that because I forgot, but you can say int is equal to 10. So you start with 10 and then you do a minus minus here, right? And then you say loop while I is greater than 0, like this. So this still works just fine. You just start at 10 and then count down to 0. So once it reaches 0, it will stop because now I is no longer greater than 0. So you can do this in reverse as well. Same thing here. You can just swap these and check for while I is less than 0. You just start at 10, for example, and then you check while A is greater than 0. And then here we do A minus minus, like that. This still works just fine. It's just that it will count in reverse. So as you can see here, 9876 up to 0, as opposed to this part here. So those are things to do. Now, what about the do while? Now, do while is just like while. The only difference is that we do, and then that's when we run the while statement down here. So what we are doing essentially here is that we start by doing the action once and then check the while condition. If it's still met, then we loop again. So you use the do while loop if you need at least one of the, because previously the way the while loop was is that it first checks the condition. So if the condition originally isn't met, the loop will not run at all. It will not start. But like this, you can say do, and then it runs the thing once and then checks for the condition and then keeps running for as long as the condition is met. So let's try this out and see a difference. So let's do that. Okay, so what's expected here is a semicolon at the end. So it really shows me where I should put the semicolon. It says JavaScript error. This thing expected here. So no problem, man. We're gonna add that semicolon there, save, and let's retry. And there we go. So starts at 9. It doesn't look very different at all. It looks exactly the same. That's because all of the conditions do run. But if, let's say, the condition is never met, for example, let's say if A is equal to 100, I know A will never be 100 because we are starting at 10 and then reducing the number every time. So while A is equal to 100, loop. So I know this condition will never be met, but at least this will run once. So I'm going to try this again. You will see it run only once and then continue. But if we move this to this part like so, same condition, right? Same code, everything. We've just changed it to a while loop instead of a do while. You will notice that it will not run at all, right? So nothing ran there completely. So that's the difference between a while and do while loop. Right, so this is how you repeat stuff in programming. So hopefully you have learned something new here, and I will see you in the next tutorial.